my name is David Beamonte, and I am Product Manager for IoT and Embedded Systems at Canonical, the company which is behind Ubuntu. Before we get started, I would like to thank TIBCO for inviting us to this event. We are really happy to be here and help developers create edge analytics applications. In a few minutes, Marcelo will show us how to deploy edge applications using Project AIR. But before that, what I'm going to do is to introduce some of the tools and artifacts that he's going to use. Basically, he will be speaking about some packages called snaps that are running on an operating system called Ubuntu Core. So let's try to shed some light on these topics. So let's get started with the snaps. What are snaps? Snaps are containerized software packages which are bundled with their dependencies, and they are isolated from other packages and the system through interfaces. They have their own sandbox and writable area independent of the rest of the snaps and the system. And they are not containers like Dockers, which emulate the operating system, but they are applications that run on top of the operating system. Every snap is based on a base or core snap, which is a layer which makes the application feel as if it is running on top of a specific Ubuntu LTS version, such as Core 16, 18, or 20. But the applications are actually running on top of the system with that intermediate abstraction layer, acting as their runtime environment. The use of this abstraction layer and the fact that the snaps include the dependencies and libraries needed by the application make that most portability issues completely disappear. Transactional updates are one of the most important features of snaps. Updates are either pushed automatically from the snap store or requested on demand from the device. Upgrades and updates are inherently secure, and we like to say that they are bulletproof and mission critical, mainly because on the one hand, because the snaps are signed by default, and on the other hand, because during an update, the original package's binary and data are kept until the new release is installed. And so if the update process fails or the new service doesn't start or breaks the system, an automatic rollback is performed. Snaps are also compressed, which allows saving bandwidth and time, but additionally, during updates, only delta data between versions is transferred, which makes it optimum for limited connectivity scenarios, which are quite typical when using cellular technologies such as narrowband IoT or Cat-M1. Snaps can be used in many different operating systems. They are not constrained to Ubuntu, but in Canonical, what we have done is to go a step further with the snaps. What we have done is to create a new operating system based on them, which is called Ubuntu Core. Here we can see the high-level differences between Ubuntu Core and a classic Linux distribution. Classic Linux distribution's architecture is based on applications deployed as packages, which simply interrelate with each other. But with the appropriate permissions, they have full access to the full system. In Ubuntu Core, all the applications are based on snaps. And these snaps are strictly confined. So they are totally isolated from each other, and they can only interact with the system through the interfaces. In summary, what we have is an architecture which delivers better security and a stronger resiliency. In this new operating system paradigm, even the bootloader and the kernel and the distribution base are snaps. Everything is a snap, and only snaps which are strictly confined can be installed. So Ubuntu Core is Canonical's proposed operating system for the next generation of Edge and IoT Linux-based devices deployed at scale. The main goal is to secure the new flavors of SmartThings. Ubuntu Core is a lightweight core version of Ubuntu, removing all the unnecessary packages and so reducing footprint, which makes it suitable for machines with constrained resources and for a great variety of architecture. It is an operating system designed to be hardened for security in different ways, such as cryptographic methods, which are applied to features like secure boot or full disk encryption. And this is really important because we want to protect our devices against vulnerabilities. And so a continuous effort on CV fixing and robust deployment of security and application updates is crucial to keep our devices secure. So commodifying the operating system and the services around it, the services which provide security and updates, with that, developers can focus on their application and business case, which improves productivity and reduces time to market. We also want our devices to be in the field for many, many years, and we want to feel confident that they are going to keep secure for their whole life cycle in the field. So the up to 10 years of support and security updates provided by Canonical is also a key feature for that. So in summary, Ubuntu Core has been designed to be the best-in-class and reference operating system across all the edge and IoT verticals deployed at scale. IoT gateways, AML, consumer electronics, digital signage, robotics, automotive, or industrial applications are just some examples where an ultra-reliable and enterprise-grade operating system like Ubuntu Core is definitely needed. Okay, so let's dive a little deeper into the process of snap creation and Ubuntu Core image generation. Okay, first of all, let's start with the snap creation. This is done in the machine that we use for development. First of all, snap is described by a YAML file called snapcraft.yaml. This file consists on 3 main blocks. The first one includes top-level metadata with information such as the name of the snap, the base snap. In this case, in this example, it is Core 18. A summary, description, and additional info as grade or confinement, which identifies how secure and isolated the applications in the snaps are. The second block details how applications and services are exposed to the host system. And the third block identifies the parts describing how to import and potentially build each required part of the snap. In this case, for instance, we are going to build a Hello World application, which is downloaded from that URL. So using a tool called Snapcraft, we create the snap. The snap is the binary package that includes the application and all the dependencies and libraries needed to run it. This snap file could be copied to the target device and installed manually. That's something that can be used for development purposes, but for production, it should be deployed from the Snap store, which is the repository where all the snaps are hosted. To publish the snap to the Snap store, we need to use the same Snapcraft tool to log in and to publish the snap. Once the snap is in the store, updates can be requested manually from the device or pushed from the store to a fleet of devices. We can use the previous process to build and deploy applications to any system which supports snaps. But as I mentioned earlier, we can also build a full operating system built from, based on snaps, which is Ubuntu Core. This process is also quite straightforward. Okay, the idea is to generate a signed binary image which contains everything needed to boot a device, such as the bootloader, the kernel, and the different partitions with the root file system. And that binary image will be flashed in the device. So first of all, we start creating an SSO account needed for creating and registering a key. That key is used to sign a model file, which is a JSON file that includes all the information needed to generate the Ubuntu Core image. And that is done with the command snap sign. The resulting signed file is called model assertion, which is also a text file including a key and the rest of the information from the model, the JSON model file. And the last step is to generate the image with the command Ubuntu image using the model assertion. So the generated image is a binary that can be flashed in the boot-in storage device or of the device that we want to use. Okay, so that's it from my side. Before jumping to Marcelo's presentation, I would like to highlight that you can find additional information in the following links. And thank you very much for your attention. Over to you, Marcelo.
Thank you, David. Hello, my name is Marcelo Gallardo. I am with TIBCO Software, and currently I am working on TIBCO Labs Project AIR. Before jumping into continuing with what just David demonstrated, show us, I want to give a very quick overview about Project AIR. So what is Project AIR? So Project AIR is a framework that is built on top of other open source projects like HX Foundry, which provides facilitates the management of devices and also helps you integrate with your applications on the cloud or your existing applications on the backend. So the Project AIR takes an agnostic approach to select any cloud provider on edge device while using open source technologies. With that said, let me just provide you a quick high-level overview of all the capabilities provided by Project AIR. So as I mentioned, we allow the connection and extraction of IoT data for processing. We also allow the management of data at the cloud or at the edge. Also, and we allow the creation to trigger to create business processes that can be deployed either at the edge or at the cloud. Also, we allow that to feed into long-term big data repositories for historical analysis and the machine learning of the data that is coming from the devices, and all of that can be done at the cloud. We also provide a user interface that allows us to visualize and explore the IoT data, and I will be showing a little bit of that. We also allow to monitor, measure, and react to IoT events via customizable UX. So the user interface that I will show can be modified according to the needs of the specific use case or scenario. And we also allow to combine IoT data with AI and machine learning models. With that said, let me jump quickly into a high-level overview of the architecture, and I will explain how we are going to use the snaps for the specific components that we are going to be showing in this demo, the components that are going to be running at the edge. So the architecture for Project AIR is made up of three parts, and the components that run at the edge. That's where we have the devices, the sensors, the gateways, and where all the data generation is done. And then in the middle, we have the IoT platform that we provided with Project AIR. Some of the components of this platform run at the edge, and some of the components run in the cloud or on premise or wherever is required. Actually, everything can be running at the edge, or everything can be run at the cloud. It just depends on the scenarios. And this layer provides like data ingestion, data management, analysis, policy and orchestration, and device and platform management. And on the right-hand side, we can see the enterprise applications, where we have all the business application, business processes, and all of these processes interacting with the edge devices and providing contextual data to the processes that we want to create. So in this demo, I am going to show you, as here we can see the architecture, and on the left we can see the devices and the IoT gateway. That's where the HX framework will be running. In this case, we will be simulating running on an AWS instance running somewhere in Seattle. And then we also have, we will demonstrate how we are going to create the Project AIR basic components that are required to be running on the edge in order to integrate with our other components that run on the cloud and integrate with the enterprise applications. So let me get out of this. Actually, let me jump into another. Let me show you this. So what I will show you in this demonstration is we're going to make use of snaps. Dave just show us all the infrastructure, that all the components that the Project AIR provides for the edge. We are going to deploy them as snaps. So the first set of snaps that I have already started and I have installed are the HX Foundry components that are deployed using the snap. So the only command that I have to run in order to get these components up and running is just run the sudo command, use a snap install, and then provide the channel I want to use. In this case, I want to use the latest version of a stable version of Ajax. So I put a channel Hanoi, and then I provide that I want to install the Ajax Foundry snap. And also for Project AIR, we have created a couple of snaps that provide the main framework that needs to be running at the edge. So in this case, we have a agent component that allows to communicate with our cloud components, and provides the capability to create new processes and deploy those processes dynamically at the edge. And also we are going to, I am going to show we have installed another snap that provides a component that publishes all the metadata for that specific edge gateway, which will allow us in the Project AIR user interface to interact with those components. So let's jump into the demo. So before I go into my user interface, I have here a command line that shows all the things that we have installed already. So I will just run a simple command, is the snap services. So this will show me the list of snap services that are already installed and running. So you can see here all the Ajax components have been started, and some of them are active and enabled. Another command that is very useful is a snap list, and this shows all the snaps that have been installed on this machine. So here we can see that we have the Ajax Foundry components installed. We have a Docker snap that has been installed. And also we have these 3 Project AIR components. The one, as I mentioned, the metadata component that publishes metadata information about the gateway. We have a device simulator. And also we have a service that converts messages from 0NQ to NQTT. So those are the required components required by Project AIR on any gateway in order to interact with the user interface. So let me jump now into my Project AIR user interface. Move a little bit this so I can right here. So here I am at the Project AIR interface. I am going to log into the application. So now that I am logging, I will get started. And the first thing that you see when you get started, you will see a list of the different gateways that you are connected, that you are able to manage. So in this case, I have created one gateway that is actually running on my local machine. So this gateway, I call it Mac home devices. So I have a few devices that I am monitoring and managing from here. So like, for example, if I go here and view the details of this specific gateway, I can see I have a camera that I am managing from this gateway. And on the right-hand side, I can see all the different sensors associated with this camera. So for example, if I go to check this sensor that gives me the number of miles, I can see on the bottom a history of the data coming. But right now I am disconnected, so I cannot see any data coming at this time. So going back to my gateways screen, you guys can see I am managing only one gateway. But now in this screen on the console, I am going to actually start the snap that for this AWS instance. So right now my user interface doesn't know anything about this new gateway that I am going to start. So I am going to start this service metadata snap. It's started. So when this happens, all the components that are running on the edge start publishing data securely, and my infrastructure on the cloud will discover automatically that gateway. So hopefully things will work. And let me refresh the screen. And in a few seconds, we should be able to see that we have a new gateway available that we can start using and manage. So here you can see I have this AWS Snap Gateway. So this is we were able to start everything on the on this machine just with a simple command that allow us to install all the components using a snap and then just get it started. So once that the infrastructure is running on the edge, we can start interacting as any other gateway that was started with a different method that is not a snap. So for example, in this way, the gateway that I run running on my local machine, I started just using Docker, but for this other gateway, we started everything with the snaps. So once that we have that started, I can start interacting with those that gateway. So for example, here, if I go and see the details, I can see that I have I started also a simulator adapter. So in this case, is an electric charger adapter that I am simulating. So I can see the details here of that specific device. And here on the top, I can see the different sensors on that device. So here, if I click here the status and here on the voltage, I can see the data. But at this time, the device might be generating data, but I haven't created any business process or anything to make use of that data. So that's what Project AIR is very useful, because here we can go to the gateways and select to create, sorry, I exit from there. So here we can start creating the different pipelines that of business processes that you want to deploy to either to the edge or to the gateway. So here, when we click on the pipelines, we are taken into this editor where you can actually create your business processes. So let's create one simple one. So let's create this a basic pipe. And in this one, the only thing that we will do is take the events from that simulator and send it to the cloud. So it's going to be a very simple business process. So here on the type, I am going to select the edge. This means that the process I am going to create is going to be created and deployed to the edge, in this case to that AWS instance, where we start all our infrastructure using the snaps. So here we will just give it a description. And here on the left, we are going to start creating actually the business logic. So the first thing we're going to select is a data subscriber activity. So here we're going to subscribe to the data coming from these sensors that are running in this gateway. So here I select the edge MQTT. That's where data is coming on this specific gateway. So here we can see a summary of that endpoint. And now we are going to just select another activity. Here we're going to put a data publisher. And here we select the data publisher. And we are going to select this to send to the MQTT instance that's running on the cloud. That's for Project AIR. And once that we have the two activities set, we can connect the activities. And that's it. That's our first business process that we have created. At this point, we can save it. Once that is saved, it is available here on a table at the bottom that we can use at any time to either modify it or add more features or whatever is required. And then finally, you can just come here and deploy. So when I click the deploy command, all this configuration that we saved here on this, when we create this process, is converted into a Flogo application, which is then converted into an executable depending on the platform that the destination machine is expecting this. So in this case, we are going to create an executable to run an AMD 64 processor, and then that executable is containerized and then finally deployed into that machine. So right now, the process should have been actually created and deployed and it should be running now in this AWS instance. So let me see if I have here another window. Let me open. I am going to go to that machine and open the container user interface on that specific machine. And then here, if I go to the containers, I can see here that this is my process that I just deployed. So if I go to my user interface here, you can see that the name of this process is called, the ID is 50917. So if we go here to the container that shows all the containers that have been deployed here, we can see that that specific instance is running there. Again, if let's say that you are not happy with that instance, that you need to make changes, so you can come here to the editor, you can click undeploy. So the instance is removed from that. So if I go back here to container and refresh this, we will see that that instance that was deployed is gone. And again, now we have the capability here to come edit this process or create actually a new process. Let's say that you want something more complex. So we can say, let's say we want a subscriber. We select the source of the data, in this case, the HMQTT. Then we can, for example, create some filters. Let's say that you don't want all the data coming from the source, but you want to filter some of the data. You can come here, connect, and here on the right, you can be able to see the devices that are coming on this specific gateway and all the sensors. So let's say I don't want the status data or the voltage, I just want the current and the energy data. So that's all I select. After that, you can create more activities. Like for example, you can create, let's say that you have a model that can infer data from the data that's coming, then you can select the inferencing. But again, this has to be pre-configured. Some models, in this case for this demo, I haven't configured that. You can also create rules. In this case, also you can do a streaming of the data. So let's say we want to stream, let's say that for the voltage, I just want the average of the data. So let's connect again. So here I can select, okay, I want to select the device. So let's select the electric charger, select the sensor. I want to do the streaming. So in this case, I want to select the current, and then you can specify any operation you want to do the streaming. So in this case, I want the average. I want to use a sliding window, and the size of the window, I leave it at default 5, and that's it. So that means that whenever we will receive data, the data won't be sent to the next activity. In this case, let's say we want to send a publisher here. We want to publish this data to the cloud. And we can connect these two activities again. And here we can select, we want to send to the cloud MQTT. So again, so just a brief summary, we are subscribing to all the data coming from all the sensors. Here we filter the data for 2 specific sensors. And then here on the next activity, we are going to do some streaming for one of the data from those sensors. We are going to just send the average. Hopefully this has been helpful for you guys. That's the end of the demonstration. And if you guys have any questions, I'll be happy to answer if we have time.